So real quick, what's a rational function? It is any polynomial over another polynomial. But what is the most important condition to remember? The denominator is not equal to 0. Just like a rational number is anything in the form p over q as long as the denominator is not equal to 0, the same thing. It's a polynomial over a polynomial. That's what a rational expression is. So far, we're only talking about rational expressions. It's a polynomial over a polynomial. Now let's look at a few examples. We've in the previous video, we were evaluating rational expressions, which means we were plugging in the given values of x to figure out the value of that expression. Now, we're going to look at each expression and think about when exactly is this rational expression undefined. Okay, so let's look at number 8 from your textbook, x over x minus 1. So we have a polynomial in the numerator and a polynomial in the denominator, and that makes it a rational expression. Now, when is a rational expression undefined? When the denominator is equal to 0. So if we set the denominator equal to 0, we can figure out the values at which the denominator is equal to 0. So the denominator is x minus 1. Let's set it equal to 0. We're just trying to see which number would give you an undefined value of the expression. So we solve for x. So add 1 on both sides and you get x equals 1. So if you plug in x equals 1, and if you want to double check, you can do that. So x over x minus 1. Plug in the x, so it's 1 over 1 minus 1. So it's 1 over 0. Remember what we talked about. The denominator cannot be equal to 0. So that's what we're trying to determine. For what values of x is the denominator equal to 0? And that's why we set the denominator equal to 0 and we figure out the values of x at which the denominator is equal to 0. So this expression is undefined at x equals 1 because that makes the denominator equal to 0. Next, let's look at the number 10 in your textbook. So x minus 1 over x squared. So we have a polynomial, which is x minus 6 in the numerator and x squared in the denominator. A polynomial over a polynomial is a rational expression. And we are trying to figure out when this rational expression is undefined. So denominator is equal to 0. This is when it's a problem. If the denominator is equal to 0, the expression is undefined. And we are trying to find the values at which the denominator is equal to 0. So let's plug in x squared, the denominator equals 0. X squared can be 0 only when the value of x is equal to 0. So what does this tell us? If we plug in x equals 0, the expression becomes undefined because it makes the denominator equal to 0. So that's our focus. We want to make sure denominator is not equal to 0. So we find values of the values at which the denominator is equal to 0. And that is at x equals 0. And that makes the expression undefined. So at x equals 0, the given expression x minus 6 over x squared is undefined. Let's look at the next one. We have a polynomial in the numerator and a polynomial in the denominator. So we're looking at problem number 12 from your textbook. What is it that we need to find? The values of x, the variable at which the denominator is equal to 0, which is the same as saying the values of x at which the rational expression is undefined. So we have x squared minus 9 equals 0. We set the denominator equal to 0 to figure out the values at which the denominator is equal to 0. Now, how do we solve this? There are a couple of ways in which we can do this. We can do this by factoring. It's in the form a squared minus b squared. It's a difference of squares. And we have a standard expression, a plus b times a minus b is equal to a squared minus b squared. So we can go x minus 3, because 9 is 3 squared. Well, let's just write that down. So we have x squared minus 3 squared equal to 0. So that is x plus 3 times x minus 3 is equal to 0. Now, this is the 0 product rule. If the product of 2 is equal to 0, we set each one equal to 0. X minus 3 equal to 0. X equals negative 3. And x equals positive 3. So if you subtract 3 from both sides, add 3 on both sides, you can solve the equation. Another way of solving this would be x squared minus 9, so this is the second method, is equal to 0. Solve for x squared first. So x squared equals 9. And that gives us x equals plus or minus, you take square root on both sides, plus or minus square root of 9, which is equal to, and I'm going to write the answer here, x can equal plus 3, because the square root of 9 is 3, or minus 3. So these are the two values at which this expression will be undefined. Let's double check. The expression is x plus 1 over x squared minus 9. I'm going to plug in, let's plug in one of these. I'm going to plug in x equals negative 3. So negative 3 in parentheses, whole squared minus 9. And that is also negative 3. Wherever you see an x, put a negative 3. Negative 3 plus 1 equals negative 2 over 9 minus 9. And what happens when the denominator is 0? The expression is undefined. So let's do the next one. I'm going to write it here. So this is a polynomial in the numerator, a polynomial in the denominator. So this is a polynomial, this is a polynomial. A polynomial or a polynomial is a rational expression. When is this rational expression undefined? When the denominator q, so let's set the denominator. The denominator cannot equal 0. Set it equal to 0. And now let's try to solve it. We can factor this expression. So that's a 1 times negative 12 equals negative 12. We can go negative 6 times positive 2. I'm just writing different things here. Positive 6 times negative 2, negative 4 times positive 3, and positive 4 times negative 3. Different ways in which you can get 12. I'm sorry, a negative 12. But what works for us is this particular product. So basically what we're going to use is negative 4 times positive 3. This is times positive 3 is negative 12, and also negative 4 plus positive 3 is equal to negative 1. And that works for us because we have negative x So technically this is 1x squared plus negative 1x minus 12 equals 0. So the coefficient of x is negative 12 and the sum of the two has to equal that. Now we're going to rewrite the expression. We'll write the negative x as negative 4x plus 3x minus 12 equals 0. Now we factor by grouping, factor the x out. So x times x is x squared, so one of the x's goes out, so you're left with 1. There's 1x here, you remove it, factor it out, you get a negative 4 plus, factor the 3 out, and 3x is left with just an x because you factored the 3 out. 3 times 4 is 12 and that's equal to 0. So x minus 4 is a common factor between these two. We factor that out, so between these two that's a common factor. We factor that out and we are left with x, and take the sign as well, plus 3. So this is equal to x minus 4 factored out times, and the yellow is what's left over, and the sign is plus 3 equals 0. Now the zero product rule says either x minus 4 equals 0 or x plus 3 equals 0. Adding 4 on both sides, we get x equals 4. Subtracting 3 from both sides, we get x equals negative 3. So x equals 4 comma negative 3. So these are the values of x, the variable at which the denominator becomes 0. And when you plug in these two numbers, the expression is undefined, which means just plug in 1. So you get 2 times 4 plus 2, I'm plugging it into the actual original expression, divided by x squared, so that is 4 squared minus 4 minus 12. So that is equal to 8 plus 2, that is 10 over 4 4s is 16, minus 4 is 12, 12 minus 12 is 0. So that's what gives you a 0 in the denominator. If you solved the equation correctly, then these two values are the values at which the rational expression is undefined at 4 and negative 3.